Okay, I have another LG 50PS3000 to repair. Thought I'd do a video of this one. And I have a video of another one of these that I fixed that was a different fault to this one. The other one, we had an intermittent VS on signal from the main board, which was causing the VS rail to drop out intermittently, and that was just a main board problem. This one today, however, is another issue which I actually mentioned in that video on the Z-sustain. Basically, we have a very poor display on this one. So I'll switch it on here. Find a way to lift this up. I don't know if you see there, but the display is very poor. There's a lot of red in the display, like there's too much red in the display. It looks like a load of maldischarge. That is actually called maldischarge, otherwise known as red haze. Basically, the pixels aren't discharging properly for one reason or the other. It's likely just the Z-sustain at fault here, which is this board located over here. I'll show you that when I take the back off. There's a common fault on this. There's, I think, 3 transistors, a 10-watt resistor, and a couple of 5-watt resistors, and a surface mount one that fails. And there's also, I think, about 9 100 microfarad 25-watt caps on the control board that also fail, and I believe contribute to the failure of the Z-sus. So I'll take the back off in a minute anyway. I've got a bit of a cold right now, so you have to excuse that. But for this, in this video, I'm not going to be using my oscilloscope to test this. See, what I would do is look at my oscilloscope and test the waveform of the Z-sustain, and if it's incorrect, you know, it'll help me diagnose it easier. It is easier to use an oscilloscope, but you can use a multimeter. And I'm also not going to use an isolation transformer. If a guy called Tim Hode is watching this, he commented on my video of the other one of this that I fixed, bitching at me for not using a isolation transformer. Really, I haven't needed one. I've been shocked a few times, yes, but nothing to the point where, you know, I'm dead. I'm still here. He was a bit of a wanker, whoever he is. And actually, I fixed 450 TVs. I've actually got about 5 more to add on there. I forgot to add them. I was going to add them today, but I thought I better not add them for the video because it'll say that I updated it today, and then, you know, people could say that I've just made that up. No, that is an exact figure. Well, a few more that I've done over the last the last week or so that need to be added. But yeah, 450 TVs. I'm still alive, so. Yeah, Tim Hode, if you watch this, just fuck off. Anyway, what I'm going to do is take the screws out. There's several screws around the edge and on the main board there, and then we can take the back cover off and we'll have a look at this and start diagnosing it. So, saying that about that guy Tim Hode bitching at me for not using an isolation transformer, ideally, when working with plasma TVs especially, and even LCDs, you should be connected to an isolation transformer, especially with the sustain boards and the power supply and the other sustain board. Mainly because these work off bulk DC capacitance. If you look at these caps here, these are for VD, I don't know what these are, probably Z bias or something, but you see there's at least 6 220 microfarad 250 volt caps all in parallel there, and of course when they're charged up, if you was to touch them and the contacts of them, you're probably going to get sent flying. Not to mention VS and VA, which are the main voltages for the sustain boards, they also have a fair amount of capacitance, 820 microfarads, I think that's VA, and nearly 1000 for VS. So, and of course, if you touch a capacitor that is charged with that, you're probably going to be sent flying, and it is best to be have an isolation transformer to help save your life if you do that. But really, I haven't needed one. You know, it's common sense really. Don't touch it when it's on. You know, and when you're testing with your multimeter, just be careful, you know, where you put your hand and stuff. I mean, the heat sinks on the power supply, normally the 3 primary heat sinks, which contain the rectifiers for the AC input, and well, mainly the primary side heat sinks, which are these 3 on this, they normally have mains voltage across them, so don't touch these heat sinks with your hand. But the secondary side ones, they're grounded, and same for the sustain boards actually. These are grounded heat sinks, so when the set is on you can touch these and you won't lose your life. But you just got to be careful, like, not to accidentally bump one of these heat sinks, because you will get a nasty shock. And just overall be careful of what you're doing. You know, if you're trying to feel how warm these heat sinks are, make sure you don't accidentally miss and touch like a resistor or something else, because you will get shocked and it will hurt. I've never been shocked by a sustain board, luckily, because a sustain board is going to be a couple of times worse than getting shocked by 240 volts AC. It makes 240 volts AC look harmless, really, sustain boards do. So just be careful, really, in it. Anyway, for this set, here's the power supply. Here's a control board. And these little 100 microfarad caps are probably going to be changed because they are problematic. They're actually 100 microfarad 16 volt. Here's our Y drive or Y sustain, and here's our Y buffer, and nicely heat sunk as well. You know, this is a full HD set, and there is only 12 buffers for the whole panel, which isn't too many. My Pioneer has 16, but it's a fair amount. But they are heat sunk on this set, which is nice. So there's a Y drive and Y buffer. It's separated into 2 modules here, so there's an upper buffer, and then this ribbon links to the lower one, which is the lower buffer. Here's our Z-sustain, which I believe is the problem. In particular, it's this transistor, this one, and this one. These 2 resistors, this resistor, that fail, and probably this cap here I've seen fail before. Well, I haven't actually seen that cap ever fail, but I've seen on the other one that I did a video of, that cap was replaced. So it's a possibility. So that's our Z-sus, and this is our main control board here. And these boards are not that good either. This crappy little heatsink for the processor. It's an LG XD engine processor. I've seen the flipping solder joints on them fail so badly, so I'm probably going to upgrade this heatsink. But it's not essential that you do that. You know, it's just something I'm doing. And I'm probably going to heatsink this processor here too, because that gets really hot as well. So I'm going to vacuum this out because it's quite dirty. And then we'll get on to diagnosing it, so I'm going to do that now. Alright, so I've vacuumed this out. I've taken the power supply out and I've hoovered underneath it, and I've also done the same to the Y main, the Z main, or the Z sustain, and under the control board. But I did put this back in to test it and test the set. So what I did was simply, to find out that the Z-sustain was actually the problem, was got my multimeter, put the black probe to chassis ground, which is just the, you know, the metal chassis here, set it to 600 volts DC, then put the red probe, you see where it says plus VZB, that's V-sustain, or it's basically a V-sustain bias. That wasn't there, that voltage, it was 0. And if I put my ear close to this area in particular here, which I said was going to be the problem, you hear a very small ticking sound repeating itself. It's just going tick, 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 which tells me that the controller that drives these transistors, because these transistors here are the regulators for the VZ bias, it tells me that the controller for them is turning on, detecting a problem, then turning off. So these transistors aren't being turned on. And without a VZ bias, which should be about 95 volts for this panel, yeah, it is 95 volts, you'll get that reddish screen like I'm getting. So, first thing I tested was this transistor here, which, get a torch, you can see this, 51N25. It's not full shorted, but the two pins at the back, I think source and drain pins, they're shorted together. That shouldn't, they shouldn't be like that on a transistor like this. On the other ones I did, these two were shorted, these two resistors were blown out, that resistor was blown out, and I think that 106S or 1R0 SMD resistor was blown out too. So I'm going to remove this FET out of circuit and test the two pins at the back again. If they are still showing up as shorted, this transistor is bad, but everything else tests good. So I'm going to take the Z-sustain out of the TV and remove that with the soldering station, and then test it again, and if it is still shorted, that transistor is going to be replaced, and then I'm going to check everything else over again. Another issue, see these caps that have full blue circle on them on the control board? They have abnormal ESR across them, which can cause the Z-sustain in particular, especially the VZ bias regulator transistor, to overheat. So I'm going to remove this and replace all these 100 microfarad caps. And then this BGA chip, which gets scorching hot, going to get a heatsink to help it cool, stop any BGA solder problems from it. And then this processor, which gets, you put it this way, after a couple of minutes of this being on, if I put my hand on it like that, I have to take it off quickly. I'm going to put a bigger heatsink on that, and I'm going to use thermal plaster, which is a lot more better at conducting the heat than what LG have on there at the minute. So this processor won't be getting any BGA solder faults like the other one I did. Of course, if you don't have that, just get like a little 30mm fan on top of there, help that cool. I might end up doing that, depends what I do. But yeah, that processor gets hot and that can fail, of course. And of course this BGA processor gets insanely hot too, so if I heatsink that, it should hopefully help this TV last a lot longer. And of course that FET there is shorted, so we're going to have to take that out and test it. So overall I'm going to take the control board and the Z-sustain out, and I'll replace the heatsink on the main board whilst it's in the TV still. So yeah, I'm going to do that now. I don't know why I'm going into depth for this, but to mount this heatsink, all I use is just silicone thermal plaster. It works really well, and you can say it's not essential that I do this, but if you want the TV to last a lot longer, and I mean it is a common issue with this chassis with BGA solder failure, you may as well fix it before it breaks, really. This is only held on by this crappy, chucked it away somewhere, it's a crappy thermal gum which doesn't conduct heat as good as it should over time. So when you get these heatsinks on here, should hopefully help the set last a lot longer. So a couple of heatsinks on this main board here. By the way, here's what I use, just silicone thermal plaster. it conducts heat whilst holding down the heatsink to the board. So I've got a bigger heatsink on the CPU there, which is a lot thicker than this one. This was only held on by thermal gum, which doesn't conduct heat that well over time because it ages and dries up. But this stuff that I've got on there now doesn't. So I've heatsinked the CPU, got a bigger heatsink on there, got a big heatsink on that RAM chip, and a little one on that one. I'm running out of these heatsinks, these little ones here for the RAM, so I put the smaller one on the one that's not directly under this, so that can disperse more heat basically. I don't know why. This isn't necessary to do, but you know, if you want the set to last a little longer, you know, you should do things like this just to help it keep chugging along. And I also heatsink this BGA chip on the control board. So it should help the set work a little better. Because these BGA chips, you know, over time when they get hot, the solder cracks on them. You know, if they get really hot like this I mean, this gets really hot still, but you know, the solder cracks on them over time, and if that happens, you'll get an issue like what happened in the other video that I did of this this same model TV. Well, different set, but the same model, if you know what I mean. So, okay, so I've got the parts that I need for this LG 50PS3000 sustain board here. I've got the one transistor for the Z-sustain that is needed, the 51N25. There's two brand new ones in here, and that one's the old faulty one. Yeah, but I ordered two just in case if it did blow out again. You know, I had another, and I could then diagnose whatever else is wrong with this board. But I've got this transistor here, and all I've got to do is stretch the middle leg of it outwards, because that's how it's set up on the board to solder it. Then clean the old thermal paste off of here, then apply some fresh thermal paste to the transistor, get the legs in the board, get the screw through the hole in the transistor, screw it down first, and then solder the legs, and then clean off the flux afterwards, and that's all you have to do. And we'll see what happens with this board. Not sure if it will blow up or not, but we'll see. And I got the caps for the control board. These are just Panasonic NHG series. For the 100 microfarads, there's 8 of them to replace, as I said. 2 there, 2 there, 2 there, 2 there. And a couple of these were open circuit as well, so they definitely need changing. So I'm replacing all 8 100 microfarads. The other ones test okay with my ESR meter, so I'm leaving them. And by the way, I got these caps off an eBay seller called Tech Kid, I believe. That's his username there. I recommend him on eBay if you ever do want to buy caps. He actually sells real, genuine caps for a really good price as well. In fact, he's that good of an eBay seller. If you use him regularly, he actually gives you free caps to test. You know, I've got these for free. I never ordered these, so yeah. Anyway, oh yeah, actually, I'll talk about removing these. To get these old SMD caps off of here, you can desolder them, and it's a little difficult. You have to heat one leg, heat the other, and then heat the other, and quickly try and get the cap off. Or you can use just a pair of pliers, and all you have to do is grab the cap, squeeze it together, and just rock it back and forwards like this. Now what this does is it breaks the legs off the cap. It doesn't break the legs off the board, meaning that you don't damage any solder pads on the board. So it can be quite difficult unless you have a pair of soldering tweezers, which is the tool used to desolder SMD caps. But as you see, that's come off, and the old pads are still there, but all you got to do is just swipe over them with your soldering iron, and then use like a desoldering iron. So, and make sure you get the polarity correct, so the edge with the like cut off corner is the positive and the flat side is the negative for these caps. And to solder these as well, that's one last final point. You'll notice that these are through hole caps, they're not SMD. all I do is flatten the legs. Might be difficult to do on video. Yeah, excuse the camera work. Oh well. All I do is just straighten the legs out like this. You might have to use a pair of side cutters just to trim these down, but all I do is straighten them out like that, and then you can just solder the legs on like that. It's really easy to do, and it does work. So, I'm going to get on with that now. Alright, so we're going to do the first power up test on video, as I normally do. And if anything goes boom, we'll capture it. It shouldn't do. Rarely I have things blow up on me, but we'll see. So straight away I can tell a difference in the sustain and buzz coming from the Z-sustain. Before it was sort of quiet, but now it sounds like it's actually working. So let's see if the image is any better. So where's the menu button here? Let's just try that. Yeah, I can already tell the image is better. Try and bring the menu up. There we go, look at that. No mass amounts of red discharge. There is some mal discharge, but that was because I was playing around with the sustain voltages previously, so they probably need adjusting again. But yeah, the mass amounts of red mal discharge have vanished, so that's good. See if we can bring this up to like a raster or something. Oh, I'll do that after actually. Don't want to get image burn, but I'll sort that out after. So one thing we want to check is, it shouldn't be, but we want to see if this heatsink has any severe overheating happening. So it's getting really hot in a short amount of time. And if it does, you still have a problem. But let me just see. And it's cold. This heatsink's getting a little warm, so is that one. And it is a little warm, but it's not overheating. Let's see how hot the CPU is. And the CPU is really hot already. The RAM, a little warm. Let's see the control board heatsink, that's pretty warm as well. So yeah, there isn't any overheating going on here, which is good. And if there was, it'd get really hot really quickly, if you know what I mean. And you will have to do more repairs to it. But normally, from what I read up on bag caps, replacing the caps on the control board, like I've done, actually stops that overheating and stops these transistors shorting out. Probably because those caps filter the line for the drive regulate, or the regulators for the CPU on that, and of course if that voltage goes lower, the regulator will see a lower input or output, which will send signals to this, which will overheat things pretty much basically. But yeah, this heatsink's nice and cool, transistors are running good. And that CPU is burning hot straight away. That's why the other one of these that I had a failed BGA solder. It was because of how hot these LG XD engine CPUs get under here. I need to make a video on those actually, I think I said. But these little XD engine CPUs, they get so hot and LG fail to heatsink them properly. I mean, that heatsink that I've put on is not adequate enough. Ideally it should be fan cooled or something. But LG basically don't heatsink these properly and they fail. And again, that control board processor on there, that's also burning hot. I mean, simply if LG would have engineered this properly, I mean, I'm not entirely sure if the bag caps on that control board are what caused the failure on the Z-sustain. I know they can cause overheating on it, but I'm not sure if they do cause the FET to short. But look at that heatsink on those 3 FETs, so that's just insanely small. You know, they should have put a bigger heatsink, or at least put a fan above the sustain boards and the power supply, and heatsink the main processors adequately enough, but they didn't, to save money basically. which results in TVs failing. But yeah, that transistor that I replaced, that one there, it wasn't a dead short across it. It wasn't actually even a dead short across the source and drain pins. I don't think. It was about a week ago since I tested it, but I think it was a leaky short across it. So of course, as soon as it got hit with the voltage it was supposed to be taking, it probably just broke down and caused the protection circuit to shut the Z-sustain down. Even if you have a VS or the VS input connector disconnected from the Z-sustain and every other connector, and you still have it connected to the panel, it will actually still make a buzzing sound because of the induction across the panel from the Y-sustain if you have that plugged in. So yeah, what I'm going to do now is just run it for a little bit. If it all tests good, put the back on and get it all tuned in and stuff. I need to adjust the sustain voltages, as I said, because I did have a mess with those before, so there's a bit of maldischarge on there. So yeah, I'm going to do that and it seems to be fixed. Alright, so I'm done with this LG 50PS3000 and just do a quick final overview. I've adjusted the VS voltage back to what the panel chart says, and I did check the VZ bias and that's all good. So on the control board, replaced 8 and 100 microfarad 16 volt caps that are commonly prone to failing and causing issues. I heat sunk the main processor because that gets burning hot. I've just hoovered all the boards off as well. And the main board, put a bigger heatsink on the main CPU. This isn't essential. You can replace the thermal pad on it though with some thermal silicone. That'll help it cool a bit better. I've just heatsunk the RAM and that, but the real repair on this is on the Z-sustain. I replaced the one transistor, I think Q15, which is a 51N25, which was I think sort of shorted or leaky, I can't remember, but it was failed either way, and probably when it got hit with the charge voltage it broke down and tripped the protection circuit on this, causing the VZ bias area not to work. So I just replaced that and the set works. But normally sometimes what can happen is, I think if this shorts, it'll blow out these two resistors. This cap can get damaged or something. This 10 or 5 watt resistor here, 5 watt actually, can get blown out, and that 1R0 resistor can get blown out too. That's actually included in a repair kit on eBay. So that's it, it's all working good. So let's put the back on and I'm going to get it hooked up to the Freeview to test. Relatively easy for me, unlike that Samsung there, which has blown up now twice. The Y main has, which has been a bit of a nightmare, but we're going to seal this up and run it now for 24 hours to test it. So, and that's how long I test TVs for.